Hello, ladies and gentlemen. Welcome to another edition of Light Bites. My name is Nathan Isidora, and this webinar is presented to you by Philips Lighting University. Our webinar today is titled Healthy Lighting for Quality Senior Living. Our presenter today is Tom Butters. Tom is a Senior Manager at Philips Lighting University in Toronto, Canada. Tom has over 29 years of experience in the lighting field and has just been named President of the Toronto section of the IEF. Now, before we get underway, I'd like to direct your attention to the right side of the screen, where we have the chat box and the Q&A box. If you're facing any technical issues or difficulties, please state so in the chat box. And if you have any questions for Tom, please state them in the Q&A box, and we'll try and get to those questions at the end of the presentation. And now, without any further ado, I'd like to give it over to Tom Butters.
Thank you very much, Nathan. Good morning, good afternoon, and good evening to everybody here. I have the pleasure of presenting you a very short light bite on quality senior living and healthy lighting for that. It is a very passionate subject for me, and typically this presentation can be anywhere from 90 minutes to 2 hours, so I've had to cut down and only talk about the very important aspects, or they're all important actually, but the very rudimentary issues. So if we look at the agenda going forward, there we go. Light bite, so outline, we're going to talk a little bit about the demographics. We're going to discuss the issues, what are happening to our eyes as we age, and by the way, it's happening to all of you, as the eye is the first organ that totally matures, and that happens somewhere in the age of 3. We'll also discuss the consequences of these changes, what is actually happening. Unfortunately, I teach this, and I'm 51 years of age, and these things are coming at me. I'm going, oh, not that. And then finally, we'll discuss some lighting solutions, some very simple aspects that we can do to help the individual, to help me actually, as we age, in being able to see and have a much happier lifestyle. The information that I'm going to be delivering to you primarily comes from these 4 publications, 2 IEF publications, Canada's Aging Population from the Canadian government, and from the U.S. government, Why Population Aging Matters. Now let's first talk about demographics. The aging population is growing. The baby boom ended in 1965 is certainly growing. By 2030, there's every indication that the aging population above 65 will double. It is also quite likely that for the first time in humankind, that there will be more people over 65 years of age than under 17. Another aspect of the demographic, which sometimes gets forgotten, is the fact that as we age, we become more and more dependent upon our environment. When we're younger, we run outside. When we're middle age, we slow down a little bit. By the time we get into our senior years, our whole world shrinks a little bit. We don't go out as often. We're left in one specific space. So here's the demographic, and this is of Canada, but it's global. It's a global phenomenon that we are, as a species, we're getting older. You can see that this is the population of all individuals in Canada from 65 years of age and 85 years of age. And presently, we're about at 15% of the population is above 65 years of age, but by the time we get to 2041, we'll see that rise to about 23%. Globally, we can see that the increase from 2005 to 2030 of people above 65, the increase is 104%, which is in fact double. And as we look up the older and the older we get, 151% of people over age 85, that'll be that increase. And you don't have to look at those graphs. It doesn't matter which part of the world you're in, you will find these graphs all the time. We as a species right across the globe are getting older. In this slide here, I love this slide. Now, it's a couple of years old now, so perhaps the knee is further along the x-axis than it is present in this slide. However, let me try to explain what we have with this slide, and then I'm going to add a couple of graphics that I think really explain what this is about. Along the y-axis, we see the percentage of individuals who would be that age that are surviving. Along the x-axis, yes, the x-axis, is the age in years. The pink are those individuals that are healthy, can move and go about. The blue are those that are ill but without any disability. And then the yellow or gold is the proportion who are both sick and disabled. So how we actually view this slide is we look at it as if one were to slice a cake. So we're going to slice into this cake at the age of 30. What we see, first of all, is that individuals that should be at the age of 30, the vast majority have survived. And of that vast majority, again, an incredible majority of them are in that pink, that healthy, mobile area. Now, what happens when I move my knife and I slice my cake at 75 years of age? What we see there now is, as one would suspect, less people have survived, of course. However, take a look at the pink level. Now, the pink level is perhaps 1/3 of the whole rest of the population, showing without a shadow of a doubt that as we age, we are far more dependent on our environment. And what this seminar is all about is empathy. Empathy towards those individuals who are more restricted. Let's look at the aging eye and some of the issues that occur as we age. Our pupils become smaller. Our lenses begin to yellow. Our lenses also become denser, and there is a decrease in elasticity, the ability to focus and to accommodate from near and far. Let's look at some of the other issues. Well, less light is going to reach the retina. It's estimated that one will require 2.5 times the light from a 20-year-old to a 65-year-old to reach the retina and have the same sight. Older seniors, those up to about 85 years of age, it's about 10 times. So our seniors, and as we age, we require more light. So just blast a whole bunch of light into a senior's facility, that seems to be the answer at this point, but no, that is certainly not the case. Let's take a look at each one of those. The decrease in pupil size. If we look at an individual with the age of 20, by the daytime, their pupil size is about 4.7 millimeters average. By night, it will dilate to 8 millimeters. That's a very large diameter that a lot of information and light can get through. If we go to the 80-year-old, take a look at the day, the diameter is 2.3 millimeters, which is about half the diameter of a 20-year-old. But notice at night, our ability for our eyes to dilate to allow more light in the darker areas in photopic vision is diminished by at least 3 times the diameter. And if we look at the difference, the very final column, we can see that as we age, our ability to see from dark to light and light to dark diminishes drastically. Here's a shot of some of lenses, and what we see is a yellowing effect caused predominantly by ultraviolet energy. And this yellowing will do a couple of two things. It actually absorbs blue energy, and we don't get as much blue energy through. But we also, as you can see, it gets pretty darn dark, and less light is getting through. This slide is from IES RP28, and this shows a relative transmission, so how much light is actually getting to the retina. If we look at the y-axis, this is the percentage, and the x-axis is once again the age. If we look at baseline being a 25-year-old eye, and that is 100%, by the time we get to 75 years of age, we can see that we have only 25% of the transmission. So 75% of that is being absorbed in some manner. This is the key here, this slide. These are some of the consequences of this change. Reduced visual acuity, reduced ability to be able to see and focus. There's reduced color discrimination. Our ability to see, because of the yellowing of the lens, our ability to see color diminishes drastically. When we look at individuals who might have a blue rinse in their hair, they don't realize that their hair is actually blue. Because of the yellowing of the eye, the hair will actually appear whiter. If they had white hair, as a 25-year-old would see white hair, the hair would look yellow to them. There's a reduced contrast sensitivity. As we age, we require greater contrast in order to see. We're going to look into this in the next slide. There's an increased time for adaptation. Adaptation is the ability to go from light to dark and dark to light. And as we age, the time to adjust for changes in illuminance and luminance increases dramatically. The final aspect, and this is we'll be going into in great detail, is even though a senior requires so much more light, as we age, we become increasingly sensitive to glare. Now let's look at the last three. This is a contrast multiplier out of the IES RT28. And what we have here is on the y-axis, we have the multiplication that one would get for the contrast. The x-axis, once again, the year. Now, what we have is different lines, and that is to accommodate the percentage of individuals in the population. If you want to accommodate for 50% of the population, you look for the black squares. If you want to look for 80% of the population or accommodate for 80% of the population, you would look at the clear squares. Now, if you take a look at an individual of 65 years of age, we can see that we have to have a multiplier of 2.5 times for individuals to see as well as when we are 20. This is a 9-inch drop here. I don't know if one can see it. This is a 9-inch drop right around here. And as we age, we have less and less ability to see that. This is actually the stairwell in an apartment complex near me. You can see that the contrast is absolutely hideous, and as we age, our ability to see those stairs becomes much more difficult, and also we become more frail. This is just an accident really waiting to happen. So how do we fix such things? Well, we should increase the contrast at areas where we have changing of stairwells, etc. Here's a good example. We can increase the contrast, or we can increase the luminance. An increase in luminance will make up for a poor contrast, or an increase in contrast can make up for poor luminance. They go hand in hand. Here again, a well-lit back stairway. Reduced contrast sensitivity, it can also occur when we're walking in through a long-term care facility. If you take a look through here and you have an older eye, we see very poor contrast with the horizontal being the floor and the vertical surface being the wall. There's also zero contrast in the doorways themselves, making it kind of confusing for individuals as they go through. Very simply, and this is not necessarily lighting, but what we can do is we can just increase the contrast. You see a great increase in contrast from the horizontal and the vertical, as well as the fact that all of the doorways are now quite marked off with very increased contrast, making it easier to make sense of the space themselves. Notice the luminaires that we have in the ceiling. Very well shielded, perforated product that we'll be discussing in later slides. There's an increased time for adaptation. If you take a look here, and you can see this slide, you see a pupil diameter of 8 millimeters. So we know that this is a 20-year-old eye. And if you've ever gone from a dark area to a light area, you will know that light adaptation happens very quickly. There's almost a pain in your eye as your eye begins to adapt very quickly from going from dark to light. And this area, you can see this in a 20-year-old, that it takes about 5 seconds. Dilation, going from a light area to a dark area, takes a very long period of time. Here we have 30 seconds just to get to 75% dark adaptation. And that is, again, for a 20-year-old eye. Seniors can take longer to respond to light level, if they do at all. This is referred to as senile meiosis. A senior can take up to 12 minutes to achieve 50% adaptation. That's absolutely incredible. So when we're in transition areas, it's very key, if you're going from a light area to a dark area, it's very key to take this in mind. I was working at a long-term care facility at one time, and there was this woman that was able to, she was in that little pink area that we saw, pink of health, and she was able to go for a walk every afternoon. Every afternoon she'd go for a walk, and then she'd come back, and she'd stay in the lobby, right in the entranceway, for a good 4 or 5 minutes. The secretary and the receptionist all thought she was crazy, but what was happening was she was literally blind as her eye had to adapt from the bright exterior into the darker interior. Now, most of us understand that we need light when it's dark. Well, for seniors, we have to understand that in entranceways, we need to have more light during the day to assist with this adaptation. This is, without a shadow of a doubt, the one graph I would like everybody to take with them and remember. This is the border of comfort and discomfort. Along the y-axis, we have luminance. So that is candela per square meter, that is measured brightness. The x-axis, once again, is of age, and the blue line that we see along here is the border where this luminance becomes glary and actually quite discomforting. So what do we see a lot in North America particularly? What do we see a lot in long-term care facilities due to the design process called a budget? We see flat lens troffers. And a flat lens troffer has a luminance rating of about 4,600. And we can see right here that it doesn't matter which age you are, that is above your comfort level. But by the time we get into the seniors right here, we can see that is far and away more discomforting. Also keep in mind, please, the field of view for a senior. When you're standing, the field of view is typically the vertical surfaces, the walls. But seniors spend more of their time sitting down. And once you sit down, your field of view often will become 50-50 walls to ceiling. And that's if you're sitting up straight. If you recline at all, the percentage of field of view that is ceiling becomes greater and greater. So we've got people leaning back with sensitivity to glare. We have flat lens troffers blaring down 4,600 candelas per meter squared, and we really just have to ask ourselves the famous question from Marathon Man, is it safe? We are almost torturing these people putting flat lens troffers in them. Here's another picture of Lawrence Olivier in Marathon Men. And why did you specify those flat lens troffers in the senior facility? Justin Hoffman should never have specified those flat lens troffers. Let's take a look at some other options that we have. Here's the perforated basket. We see these all over the place. This product is designed specifically to be comfortable to look at. And as we see here at 1200 candela per meter squared, it is very comfortable all the way into our 70s. Other products that you see in this type of application are these opal pendant fixtures. Wonderful at 1100 candela per meter squared, so very comforting right across the board. So let's look back at this with some lighting solutions as we go forward. We see this long-term care facility again with perforated product on the top, giving very good vertical luminance here. We've got the good contrast of the horizontal and the vertical, and the doorways are very well pronounced. Here we have again another long-term care facility. We've got perforated product again, giving very nice luminance. We've got wonderful windows allowing daylight in, and we've got good contrast. Now, I hear this a lot. Well, we have to because we have a budget. We have to use this product. Well, there are opportunities and solutions that don't cost as much even as that product. It doesn't have to cost a lot of money, and it doesn't have to be dreary and institutional. I like this picture because this picture reminds me of my paternal grandmother's long-term care room. It looks exactly like her long-term care. Doesn't it look like a hospital? Well, it wasn't. It was a long-term care facility. And here's my grandmother's room, and always her curtains were closed. And what does the first thing any well-meaning nurse or well-meaning family member do when we go into a space like this? We open it up and we say, oh, it's wonderful out there. Look at the sunshine. We've got direct glare into very sensitive eyes. Here's the same basic room. I mean, it's exactly the same type of furniture. And what we've done here is we've added a light shelf. Now, this light shelf allows for sunlight to come into the space, but it doesn't cause direct glare of the sunlight into their eyes. And we can see that this is a well-lit room. The same basic room, the same basic furniture, but a totally different atmosphere. Now, what else can we do getting away from this institutional look? Well, what's less expensive than a simple strip fixture? We have strip fixtures here hiding behind the valance, giving nice, even luminance. We've got a very well shielded opal drop case there. Doesn't have to cost a lot of money. What it does need, though, is some imagination from the lighting designer. Here's lighting strips at the top of a bookcase. There's nothing less expensive. You can use fluorescent or LED strips hidden away, throwing great reflected light all throughout the space. Here we have fluorescent strips down the side of the corridor, so we don't have any basic glary lights in the center, and you can see just how well and illuminated this product is, and this project is in Hamilton. The use of controlled daylight is also very important, but not direct, not windows direct right into the patient's or the tenant's eyes. Here we've got a jigsaw monitor shooting the light onto a angled ceiling, which brings a wonderful look all into the space. You can also use skylights. Again, well shielded, lights up the whole room, no glare at all. The next few slides I'm proud of. They are customers of mine, and this is the Royal Henley Retirement Residence, and they've done everything perfectly here. This is a long-term care facility. I hope that when I'm this age, that I am at a Newcomb Design residence. Wonderfully done. One does not look institutional at all. Well-shielded luminaires. The meeting area, very important meeting area. This is where they conjugate. This is where they have their social time. And that is it. I am open for questions. Please look for the new IES RP28. It's coming out later in 2014. It's entitled Lighting in the Visual Environment for Seniors and the Low Vision Population. It is a fabulous must-have if you are designing for areas where seniors are.